Good morning, all. Am I audible?
Good morning.
Good morning, sir. Shubhantra sir, কেমন আছেন? ভালো?
ভালো আছি. Very much audible.
I am after a long time. We are meeting each other.
Yes. After a very long time.
After a very long time. Welcome, Mr. Nundi.
Thank you. Welcome.
Well, little technical preparation. After a few minutes, we're going to start with the live session. After a long time, we are meeting each other. After a very long.
Good morning. Am I audible?
Yes.
Yes, sir. You are audible.
Yes, sir. Audible.
Okay, good morning to each and everyone present here, all the panelists and all the speakers. Today's discussion is all about biomass utilization. It's a technical feasibility of coal biomass co-firing for thermal power plant. And we are going to start with the webinar in just a few minutes. It's just a last minute preparation. We are just setting all the things. So if you want to share your screen, you can just check it out. The panelists, if you want to share your screen, if you want to test your thing, you can test it. Dr. Nandi, if you want to start with the preparation, you can just check the final moments preparation.
Am I audible, sir?
Yes, sir. You're audible, sir.
Hello, sir. My name is Shubhojit. Am I audible?
Yes, sir. You are audible, sir. Welcome.
Thank you, sir.
Dr. Nandi, if you want to share your screen, you can just check whether it's going in a flow or not. Just check it out.
Is it visible?
Yes, it's visible.
Okay.
Just check with the slides, 1, 2, 3 slides or something. If you have any slides, fine. Good going, sir. Thank you so much. Well, Mr. Shukla. Not on board right now. Okay. Yes, sir.
Yes. Is it visible?
Yes, sir.
Okay.
Yes, sir. Thank you so much. Just scroll down a little bit. Shubhantra sir, একটু scroll down করে নিন যাতে বোঝা যায় আপনিও বুঝতে পারবেন ঠিকঠাক মতন হচ্ছে কিনা, কোনো বাফারিং হচ্ছে কিনা। Fine. Absolutely.
আমি রেডি আছি।
Okay. Thank you so much. Dr. Bhattacharya. Suresh sir, if you have any presentation, you can share the screen.
No, I don't have any presentation.
Okay.
I'll just say a few words and then
Sure, sir. So I think we have to wait for Prafulla Chandra Dongre and Mr. Shukla. I think we have to wait for him. Okay.
So I have joined. Praful Chandra Dongre has joined now.
Yes, sir. Welcome, sir. So if you have any presentation, if you want to share your screen, you can just check it out right now so that we can move with the flow.
Yeah.
Dr. Bhattacharya, আপনি আপনার এটা মিনিমাইজ বা আপনি কেটে দিতে পারেন।
শেয়ার করুন স্যার।
Is it visible, sir?
Yes, yes. Yes, Mr. Dongre, it's visible. If you want to go with the slides 1, 2, 3, you can check this out, whether it's coming and buffering or not.
Okay, okay, fine, fine. Mm, I think it is not moving, it seems. No?
You have any other slides? Slides 1, slide number 2, slide number 3. You can just check whether it's going in a proper way or not.
No, it is not moving. Actually, I'm trying it.
Yeah, that's the thing. I just checked with my post laptop.
Yeah, please.
Yeah, this is not moving. Mr. Dongre's slide is not moving. Just check for it. I just checked with my post laptop. Yeah, Mr. Dongre's slide.
So what I will do is, once again, I will try to share it.
Yeah, sure.
Mm. No. Okay. Okay, I will check it, sir. I'll check it from my side. I will check it. Mhm. I think that screen is also not coming. What is the glitch? I think some technical glitches are there, maybe.
Okay, once we start, we'll see with that thing. I think it will be solved once your part comes in your place.
Okay, fine.
Okay.
Fine, 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 fine.
Thank you so much. Thank you.
Thank you, thank you, thank you.
Well, a very good morning to all the beautiful people present here, our panelists, our speakers, our guest of honor, and to all the participants, those who are watching here in this lovely webinar. And welcome you all in technical feasibility of coal biomass co-firing for thermal power plant organized by Engineers Welfare Forum, WBPDCL, in association with IIT ISM Dhanbad, CEA, NTPC, and National Mission on Use of Biomass. This is your host, Indos Kunal. And before starting with this webinar, a little glance about Engineers Welfare Forum, WBPDCL. Well, WBPDCL Engineers Welfare Forum used to hold this webinar live in an auditorium in Kolkata, but due to COVID-19, we are here in this web session where I think we'll have a feel of live and definitely a little bit of fun day and Sunday we'll be making here in this lovely webinar. Well, Engineers Welfare Forum, WBPDCL, they always look forward for new innovation topic where this type of webinar happens every month, more or less every month with a new topic. And WBPDCL Engineers Welfare Forum, they always put their effort to make the country better place with their works, with their CSR activities, and many, many more things. They always put up their effort on making new innovations and always stand up for the society. And definitely, it's Engineers Welfare Forum, WBPDCL. And today we are going to discuss on a topic that's technical feasibility of coal biomass co-firing for thermal power plant. And definitely, we have got associate partners for this topic, IIT ISM Dhanbad, CEA, NTPC, and National Mission on Use of Biomass. Before moving with the topic, I'll just put some light on the topic. Well, today, we all know that stubble burning has been cited as a major cause of recent smog in northwest India. Stubble burning is deliberate setting fire of the raw stubble that remains after harvesting of paddy and other crops. During the month of October and November of each year, farmers in northwest India burn an estimated 30 to 40 millions tons of crop waste from their paddy fields after harvesting. The estimated 30 to 40 million metric tons of paddy straw that remains unutilized and burned in northwest India has potential to generate about 6,000 to 8,000 megawatt and 45,000 millions unit of electricity annually by co-firing it along with coal in existing coal-fired power plants. Biomass co-firing has a potential to create a market for large-scale consumption of agro residue and convert it into electricity in eco-friendly and cost-effective manner while mitigating problems of air quality deteriorations. So we all know that it's a huge platform, it's a huge thing we need to discuss. And today we have got some lovely people, designated people with us here in this board. And I would like to introduce them one by one. And definitely it's a digital platform. We'd like to introduce them digitally. So first, I would like to request you to please put your hands together and let's welcome Assistant Professor IIT ISM Dhanbad, Dr. Borun Kumar Nundi. A huge round of applause. Could we clap for him, please? Digitally, we are sitting at our home. Could we clap for this lovely gentleman? Welcome to the board, sir. Next, we have Director TE and TD CEA, Sri Om Kumar Shukla. Sir, welcome to the board. Next, we have Senior Manager NTPC Dadri, Engineer Vivek Singhal. Could we have a round of applause? Welcome to the board, sir.
Thank you, sir.
Next, we have Engineering Officer, CPRI, and member of National Mission on Use of Biomass, Sri Praful R. Dongre. Welcome to the board, sir.
Thank you.
Next, we have our chief guest of this lovely seminar, IS Additional Chief Secretary, Power, West Bengal Government, Sri S. Suresh Kumar. Welcome to the board, sir.
Thank you.
Next, we have our panelist here, Research Scholar, IIT ISM Dhanbad, Sri Shubhojit Aich. Sir, welcome to the board. Next, we have Research Scholar, IIT ISM Dhanbad, Sri Pritam Kumar. Sir, welcome to the board.
Thank you, sir. Thank you.
And last but not the least, we have got Professor IIT ISM Dhanbad, Dr. Shumantra Bhattacharya. Welcome to the board, sir.
Thank you. Thank you very much.
Well, today we are going to start this webinar with a beautiful note, beautiful speech by Engineer Prashanta Sinha, Treasurer, CEC Engineers Welfare Forum, WBPDCL. I'd like to request Engineer Prashanta Sinha to please start with the addressing note in this lovely webinar. Welcome to you, sir.
Am I audible?
Yes, sir, you are audible, sir.
Good morning, everybody. Present here in this virtual platform with us on behalf of Engineers Welfare Forum. I welcome you all and extend my warm regards for your presence. Probably you have got some idea about Engineers Welfare Forum. Apart from our core area of interest, we at Engineers Welfare Forum engaged with various social activities throughout the year also. Today we have with us Honorable Dr. Sri Suresh Kumar, IAS, Additional Chief Secretary Power, Government of West Bengal. Professor Dr. Borun Kumar Nundi from IIT ISM Dhanbad. Sri Om Kant Shukla, Director TE&TD CEA. Sri Praful Chandra Dongre, Engineering Officer, CPRI, and member of National Mission on Use of Biomass. Sri Vivek Singhal, Senior Manager, NTPC Dadri, and Dr. Sumant Bhattacharya, Professor, IIT ISM. I thank you on behalf of Engineers Welfare Forum and extend my warm gratitude for sparing your valuable time. In this COVID situation, we are in this webinar. Coming to today's program, this webinar is on technical feasibility of coal biomass co-firing for thermal power plant. Around 30 to 40 million tons of stubble burning every year has been a major cause of smoke in Northwest India during October, November every year. Just to reduce the cost of clearing the field for next crop and reduce turnaround time between investing and sowing for the next, the farmers choose this way, but causing enormous smoke in those areas. At present, we are very sensitive to environment. We have organized programs about green energy, clean fuel, renewable energy, and importance of imbibing technology to counter emission in the past years. As we all know that government notification has been introduced time to time on use of biomass. No doubt we are ready to welcome these as a very good step to greener world by using different agro residues and biomass for coal-fired power plants. Biomass co-firing is a well-proven technology. Power plants all over the world has adopted biomass co-firing as a strategy to combat pollution. 230 plants across the globe, majority located in European and American countries, have experienced of biomass co-firing. UNFCCC recognizes biomass co-firing as a carbon neutral technology for mitigation of carbon emission from coal-based power plants. It is renewable in nature. It is available from versatile sources. It is low cost. It reduces waste for the domestic production. For this domestic production also possible. Another side, it has some disadvantages also, like that it is not clean, high cost involvement, possible deforestation, requires water, such and such. So considering all the advantages and disadvantages, it is technical challenge before us how this will be implemented. For other environment related project, we are facing similar problems, though the gravity may be a bit lesser or greater. As the engineering technology towards mass production cannot be a bereft of economy, here we encountered the conflict between technical feasibility and economic viability, and it encompasses the topic we are supposed to discuss today. Today, we have with us eminent researchers, authorities, policymakers, and site persons to share their views on this important topic. I am sure their deliberation would enlighten us and help us find ways to deal with the situation. Thank you, everybody. Let's proceed.
Thank you so much, sir. That was Engineer Prashanto Sinha, Treasurer, CEC, Engineers Welfare Forum, WBPDCL. So as I told you earlier that you used to do this thing live in Kolkata in an auditorium. So used to lit up lamp on stage. But as we are here in this digital platform, why shouldn't we do this thing here on web? So we will move forward with a lamp lighting ceremony, and that also in a digital way. So I'd like to request everyone, all the participants, all the dignitaries, please stay here, because right now we want our webinar to be a very colorful and enlightened one. So we are moving forward with our lamp lighting ceremony. So I'd like to request everyone, all the participants, all the dignitaries, stay here, because right now That's the moment, that's the lamp lighting ceremony. And now it's time to felicitate our all dignitaries here on web. First, we'd like to felicitate our dignitaries here. We have got Assistant Professor IIT ISM Dhanbad, Dr. Borun Kumar Nondi with us. Could we have the felicitation moment on screen, please? Assistant Professor IIT ISM Dhanbad, Dr. Borun Kumar Nondi, with a digital Uttorium and a digital flower for you. Next, we would like to felicitate Director TE and TD CEA, Dr. Om Kant Shukla. A lovely Uttorium and a flower bouquet for you, sir. Next, we'd like to felicitate our Senior Manager NTPC Dadri, Engineer Vivek Singhal. Sir, it's a moment for you. Next, we'd like to felicitate Engineering Officer CPRI and member of National Mission on Use of Biomass, Sri Prafula Chandra Dongre. Sir, it's for you. Next, we'd like to felicitate our guest of honor of this lovely webinar, Additional Chief Secretary, Power, West Bengal Government, Sri S. Suresh Kumar, IAS. It's for you, sir. Next, we'd like to felicitate Research Scholar, IIT ISM Dhanbad, Sri Shubhajit Ait, sir. It's for you, a beautiful Uttorium and a beautiful flower bouquet for you, sir. Next, we'd like to felicitate our Research Scholar, IIT ISM Dhanbad, Sri Pritam Kumar, sir. The moment for you, sir. Next, we would like to felicitate Professor IIT ISM Dhanbad, Dr. Shumantro Bhattacharya. It's for you, sir. A beautiful Uttorium and a beautiful flower bouquet for you, sir. Thank you. Thank you so much. Before starting, thank you. Thank you so much, sir. So it's like feeling coming here on stage only. It's like an auditorium.
That's right.
Okay, we're going to start with our presentation by our dignitaries. They will be sharing some presentation. They will sharing some words on the topic, technical feasibility of coal biomass co-firing for thermal power plant, organized by Engineers Welfare Forum, WBPDCL, in association with IIT ISM Dhanbad, CEA, NTPC, and National Mission on Use of Biomass. But before starting with the presentation, I would like to request each and every one, our dignitaries, as you know that we are bound with the time. So we have got some limited time for this webinar. So I'd like to request each and everyone to please share your presentation, limited time, that's a 10 to 15 minutes, that the designated time given to you. And so that we can move forward with our next segment smoothly. And to all the participants, those who are watching this lovely webinar, if you have any question, in your mind, you can raise those questions by writing it on the chat option. And definitely we have got a panel discussion session after the presentation of all our dignitaries, and we'll put up your question to our designated dignitaries. If you have any question to a particular person, that also you can write to Sir, Mr. or Doctor, and you can ask your question. So now we are ready with our presentation from our dignitaries, and first person who is going to come on board, he is an assistant professor at IIT ISM Dhanbad, India. He has obtained his BE and ME from Jadavpur University and PhD from IIT Guwahati. He has expertise in the field of industrial wastewater treatment, coal and biomass combustion, fuel technology, etc. He has published more than 40 research papers in all the above research areas. He is guiding several PhD and MTech in the field of combustion characteristics, coal, biomass, and their blends. He has actively participated in various industry-oriented research problems in the field of coal combustion issues of BCCL, NTPC, STPS, JSL, CEC, etc. And he is our first presenter of this lovely webinar, Dr. Borun Kumar Nondi. It's all yours, sir. Welcome to the board.
Thank you. So PowerPoint is visible now, everyone?
Yes, sir. It's visible. It's visible, sir.
So I will discuss about the feasibilities of co-combustion of coal and biomass blends. Now, whenever we go for a co-combustion study, either it is an coal and coal or it is an coal and biomass blend, basically it is a binary fuel mixture we want to burn in power plant boiler. So we have to consider various theoretical aspects of combustion, like smaller coal, that any particle having smaller particle size, they burn very fast during combustion, so they takes less time for combustion and releasing the heat. And any fuel having higher volatile material, they catch fire very easily and they ensure smooth combustion, but they ensure very fast combustion, but it may be an unstable combustion. That means suddenly releasing the entire heat within a few moments and finishing the combustion. And in the other aspect, if any fuel have higher fixed carbon, it ensures that combustion will be very smooth in a later phase, because this ignition, it will be a late, but after ignition, it will burn very smooth. If any fuel have higher moisture, from the fuel, that moisture, it will have the heat loss problem, because we know that any moisture, it will be released as a steam. So it will take both sensible heat as well as the latent heat during the combustion process. However, after releasing the moisture, that fuel can have the vacant spores, which will help in oxygen absorption and it will go for a very faster combustion. And if any fuel have higher ash, it will have a slow combustion rate, because the ash layer formed during the combustion of a coal particle, it will reduce the diffusion rate of oxygen, carbon dioxide and other gases. So, and if it has the higher ash content, obviously it will have the lower combustible material. So overall heat release, it will be very less. Also, other issues comes for the power plant. It is the during the as it has the higher ash, it will have the higher silica, alumina, or other mineral metal, which can have slagging, fouling in boiler, and issues related to the ash fusion temperature. That is the major maintenance issue for the steam boiler, boiler tubes. If we go for the ultimate analysis aspects, any fuel have the higher hydrogen content, so it will typically signifies that fuel have lower molecular weight hydrocarbons. These hydrocarbons are mostly saturated in nature. They go for a better combustion, but it will maybe an unstable combustion, because the entire hydrogen rich hydrocarbon can burn very easily. And because of higher hydrogen, it may have the lower carbon content, so it may have the lower CO2 emission. On the other aspect, if any fuel have the higher carbon content, it will have typically ensured that its molecular weight are higher, because of presence of double bond, triple bond, aromatic bond, like that. So it will go for a smooth combustion, but it will also go for a higher CO2 emission. And any fuel having higher quantity of sulfur, there is a major issues for coal and similar other biomass in some cases also. It may go for the sulfur trioxide, typically known as the SOx emission. That's why typically for coal-fired thermal power plant or similarly for steel industries also, maximum limit is kept below the 1%, so that it does not affect the quality or the SOx emission. Now, how we assess their combustion property, combustion characteristics of any of the fuel, particularly coal and biomass or solid fuel. Typically, the combustion characteristics of any solid fuel is assessed by the thermogrametric analysis or differential thermogrametric analysis. It is another instrument or similar instrument called the differential scanning calorimetry. So here, this plot or this profile, that means here we isothermally heated that coal, non-isothermally heated the coal in the heating rate of 10 degree per minute from ambient temperature to higher temperature in the presence of oxygen. Now during this combustion process. So fuel will go for a different chemical reaction. So initially it will release some moisture, then in the vacant pores, it will absorb some oxygen, and later it will catch fire depending on the hydrocarbon characteristics. Typically we call it at the ignition temperature, and then it will increase its burning rate, and at some point it will reach its peak combustion rate where the rate of mass loss or burning is very high. We call it the peak combustion rate, peak combustion temperature correspondingly, and at a later stage it finished burning. In this black curve here, it is finished burning. That means residue are only the mineral matter or ash content. So this temperature is called the burnout temperature. Now this profile, that black line, either it's the TGA curve, or this blue line, it is a DTG curve, differential thermogravimetric curve, or the mass loss curve. This profile is the, we can say that it is the fingerprint. That means depending on the hydrocarbon present, it is a aromatic, aliphatic, single bond hydrocarbon, double bond hydrocarbon, or what type of hydrocarbon is present. Each hydrocarbon behaves in the presence of oxygen and heat based on its own chemical reaction. So as a result, this TGA curve, or if we do analysis in the DSC curve, this curve is the fingerprint curve. And whenever we go for any real-time power plant design, so during this design of that power plant, typically that design people ask for the what type of coal you will be burning, that feed coal properties, what you want to burn or use in this power plant boiler. So accordingly, that power plant boiler, its dimension, its oxygen flow rate, its firing oxygen flow rate, primary oxygen feed point, everything is designed. So we have to ensure that during whenever we feed the other type of coal, we have to ensure that we are feeding that coal with very, very similar characteristics. That means this fingerprint, that this TGA curve has to be followed whatever the fuel we feed. If we deviate from this, particularly this curve, that any fuel have a different type of curves, that means that fuel have different ignition temperature, burnout temperature, peak temperature. So that fuel may be good, that fuel may have a high GCV or low GCV, but that fuel is not suitable for the designed power plant boiler. So we have to ensure that any fuel we feed that follows this ideal TGA curve that has been used during the design. This is important because many different plants have the different dimension, different design. So we have to ensure that it follows this fingerprint curve in all aspects. Now, whenever we go for a co-combustion studies, we have to see what are the different advantages and disadvantages. Typically, coal is used in all the boiler. Now, typically that at present the coal we receives or we feed in the power plant, they having the lower volatile material around or more or less than 20% PM. Very few power plant receive coal having more than 20% PM. So it has a low volatile material, low fixed carbon, low GCV, because most of the coal having the higher ash content above 40 or 45, 50%. So as a result, they having the delayed ignition problem, slow combustion rate, and due to presence of higher ash content or mineral matter, the particle density, that means the particle we feed it as a pulverized coal, those coal particle having the higher density. So it will have typically the less settling time. It will easily settle in the below of that as a bottom mass. This is a problem associated with the combustion of high ash coal. And if we go for the alternate option, people are searching, that is either the biomass, or if we carbonize it or pyrolyze it, we receive the biochar. So in Indian context, compared to the coal we received, biomass has the higher GCV. Higher GCV means if we consider the coal having GCV of around 4,000 or 3,500 kilocalorie per kg, what is typically being fed to the power plant now. So in this context, biomass has the higher GCV, higher volatile material. However, it has the lower fixed carbon. So as it has the higher volatile material, it goes for the early ignition, rapid combustion rate, and it has a very less as content. It has a very low particle density, as well as depending on types of biomass, maturity of biomass. That means biomass is full grown, or it is a partially green biomass or yellow biomass, like that, depending on its maturity level. So it has the different or wide particle density, and as a result, it has the variations in the elemental composition in terms of carbon, hydrogen, nitrogen, sulfur, their composition, etc. And if we consider energy density in terms of volume, it has a lower energy density because it has a higher storage volume. And we have to identify a suitable material handling system, like suitable type of crusher, grinder, cutter, briquetting, whatever is required. So this material handling system is ideally different from that of coal, whatever we use. And another fuel used in many cement factories and other, it is the pet coke obtained from the petroleum refinery, that petroleum coke. It has typically the lower volatile material, higher sulfur content, but extremely higher GCV. So, and it has a delayed ignition problem and slow combustion rate. So these three are the typically different fuel. We can blend it with the coal. Now during blending, we have to consider there are different properties. Like some of the properties for this fuel are additive in nature. That's like you can add them. It's like any fuel A having 1 GCV, fuel B having GCV different. By simple calculation, we can estimate their average GCV, average as, moisture, VM, etc. So these are the properties we call the additive properties. So considering this aspect, we can blend any fuel if we want to only increase the GCV or VM, moisture, etc. So here any blend ratio is accepted for any power plant. But there are some non-additive properties. Which properties? Where you cannot add itself. That means you cannot simply add A plus B. So here you have to see their individual properties is matching or not. Like fusion temperature. If any coal having fusion temperature 1000 degree, another coal having fusion temperature of 1500 degree, if we blend them, obviously coal A will fuse first, then coal B will fuse. So here not blending, it will not help. So these properties are non-additives. Similarly, that combustion characteristics, burning profiles, they are non-additives also. They are non-additive properties also. We cannot simply blindly add them. We have to experimentally verify what is the combustion characteristics of blend and individual properties of their HGI values, their grinding index, abrasion index, fusion temperature, caking or non-caking characteristics, etc. So we have to ensure individual non-additive properties has to be satisfied with the design parameters of any boiler. Here all blends are not permitted because some of the properties may match, some of the properties may not match. Okay. Now considering these combustion characteristics, whenever we blend coal, biomass or other, even if we blend two different coal, variations of burning profile parameter, just like we discussed that ignition temperature, burnout temperature, around 10 degree to 15 degree is permissible. It is permissible means it will have some problem. It will have some unburned carbon, unburned hydrocarbon in flue gas, etc. But it can be permissible within the permissible range. Higher is the difference, unburned carbon, hydrocarbon, etc. It will be in the fly gas. So this difference in burning profile should be very, very less whenever we go for a co-combustion studies. So we have to always ensure that fuel blend with properties in all respect with the design coal. That is means that coal properties has been used for the particular boiler, which is available in the boiler manual provided by the installation during installation time for the best performance. So these are that some of the typical values of this coal and biomass, whatever we have studied. My student will discuss it much more later. Typically, if you say coal, we have studied with the high as coal, typically the coal reject having as 57%, 61%, etc. And if we go for the other type of biomass, we have a very good biomass source of sal leaves in West Bengal and nearby forest. West Bengal, Jharkhand, Chhattisgarh all have a very rich in sal forest. We can have the eucalyptus leaves, we can have the segun leaves, or we can have the agricultural waste like rice straw and rice straw char. So all of them have a very less quantity of ash. We can see their VM content is very high, and they have a very typically less quantity of fixed carbon, but these fixed carbon quantities are almost similar to that of this high ash coal. And if we go for a GCB, sal leaves, it has extremely high GCB similar to any of the liquid fuel. Obviously, this is the mature sal leaves. We call it a fallen sal leaves. We call it. We receive from the Bishnupur forest. We can have the eucalyptus leaves. Is a very good GCB of 6,985 kilocalorie per kg. Segun leaves has 5,500. Rice straw typically in the lower range. There's a lower amount of GCB. Now, if you see the TGA curves, we can see that this is the actual properties for the coal, the TGA profile. And if we blend it with the different ratio like 10% biomass, 90% coal, 50% biomass, 50% coal, we can see that their profile is getting slightly different. So and if we see the DDG curve, this is the actual combustion properties. Red curve is for the coal, but biomass burning happens in 2 or 3 different stages, because it has the cellulose, hemicellulose, etc. So individual material burn in their individually. But in case of blend, we can see this green curve. It is almost similar to that of coal. So from this aspect, we can see that this green curve, that corresponding ratio may be permissible with minimum impact. But if we go for the higher ratio, it is difference that there will be 2 different stages of burning. Initially, biomass will burn, then coal will burn. So if we see the temperature, ideally it is a design like if it is a design for coal A, 449. So that blend of 10:90, that 10% biomass, 90% coal having the 415. So this is, we can see the nearby. We can use it whatever to some extent. But if you see the other ratio, they are not permissible in the same boiler. Although difference is significantly higher. So in this way, if we go for the other type of agricultural waste, here they are rice straw, wheat straw, mustard husk, wheat husk, they are being a very GCB in the range of 4,000 to 5,000 here. And here you have an option for petroleum coke, which we find by our research that which may be blended with the coal to very smaller quantity, because it has an extremely higher GCB. So, but problem is that pet coke has the very less ash, but it has the problem with that it may having the higher sulfur content. So we can see that they have the individually distinct different combustion profile of this in the TGA profile also. So in the blend also we can see how they are varying. So this black curve, we can say this is very similar to that of this coal, black line. But this other green line, if we come from 50% coal, 10% petroleum coke, 40% rice husk, it is coming far away from that green curve. So these may not be suitable for plant. If we go for a burning profile temperature, coal having 384 and pet coke having almost similar characteristics of 383. So they will burn in a similar way, but their heat release rate is significantly higher because it has a higher volatile, higher fixed carbon. So only burning pet coke, it will create a extremely high temperature, high heat release rate, which may be damaging the boiler tubes and other accessories. So what we suggest is that we can blend a limited quantity of pet coke, limited quantity of biomass, maybe 5%, 10% in this range by matching this burning profile temperature. That 384, it is 356, it is nearby. So obviously, if we go for a less pollution, we can like make it 90:5:5 or like that, maybe 92:3:5 in this ratio, so that these temperatures are very much similar to that. So if we go for a concluding remarks, that is coal with similar burning profiles is expected to behave similarly in a full-scale boiler. Burning of high ash coal, low VM coal is very, very time consuming because it has an ignition problem. And by comparing the burning profile parameters, we can just identify which biomass, coal biomass blend ratio or coal biomass pet coke ratio can be matched with the design coal. That is, compatibility may be judged, and optimum blend ratio needs to be determined and maintained during the blending. That is based on their non-additive properties, mostly just like ash fusion, temperature, burning profile, etc. And in Indian context, biomass has the higher GCV, above 4,000 to 5,000 kilocalorie per kg, compared to the high ash coal typically present to the power plant now. And maximum 10 to 15% biomass may be blended or co-fired with the coal. Biomass helps in combustion performance of high ash coal. Particularly, this biomass helps to reduce the auxiliary liquid fuel consumption, that is the fuel oil we burn in a power plant. That fuel oil consumption we can reduce by blending some quantity of biomass. Typically, the forest leaves, because they are the matured, so they are having the higher GCV compared to the agricultural biomass. And biochar, if we blend, it gives a much more blend stable combustion because it has the lower quantity of volatile matter. And very small quantity of pet coke we may blend because it has the issues with the sulfur content. We can use a very small quantity to adjust the GCV content or energy content of that blend. So thank you all. So any queries we can ask or we can take it later.
Thank you so much, sir, for your lovely presentation. And definitely some of the participants have their questions. So we will raise this question later in the panel discussion. And that was Dr. Borun Kumar, known the Assistant Professor, IIT ISM Dhanbad. Thank you so much, sir, for your lovely presentation. Next, we'd like to move on to our next presentation. And next presentation is by a person who is the Director in Thermal Engineering and Technology Development Division in Thermal Wing of the Central Electricity Authority, CEA, Ministry of Power, Government of India since last 2 years. He has around 14 years of service in different wings of CEA. Presently, he is looking issues related to utilization of biomass in thermal power plants, review of Central Electricity Authority technical standards for construction of electrical plants and electric lines, regulations and review of Central Electricity Authority safety requirements for construction, operation and maintenance of electrical plants and electric lines regulations. And the next presenter, he is Shri Om Kant Shukla. Sir, it's all yours.
Thank you, sir. Respected all dignitaries. Hope I am audible.
Yeah, you're audible, sir.
Okay. So just I'm sharing my presentation.
It's all yours.
Okay, presentation is visible, I think. Hello.
Yes, sir, it is visible.
Okay. So just the topic of my presentation is policy on biomass utilization for power generation through co-firing in coal-based power plants, just issued by our Ministry of Power. We see India in northwest India only, just 30 to 40 million tons of crop waste from their paddy fields is burned after harvesting season during winter season months during November, December. And this 30 to 40 million tons, which is around 40 to 50% of total paddy straw in Haryana, in this northwest states, Haryana and Punjab only. So this has the potential of around 6,000 to 8,000 megawatt and 45,000 million units of electricity annually we can generate from this agro residue, which we are just burning in the fields. So it can be utilized. So it was seen, and in this biomass co-firing is now is well proven technology with the increasing environmental awareness. Power plants all over the world have adopted this biomass co-firing as a strategy to combat pollution. So if we see, just a minute. Okay. So if you see, during total coal consumption, as per our executive summary released by Central Electricity Authority in 1920, it is coal consumption 622 million metric ton per just in that year, and 5% if as per policy just have been issued by Ministry of Power, if we use 5% biomass, so it is simply 31 million metric ton. So, and here if you see total surplus biomass in the country, it is around 228 million metric tons. So so much potential we have for just generation of power from this biomass. This benefits, if we see from using biomass pellets co-firing, so it eliminates, minimize the burning of agro residue and create economic value for agro residue by promoting its use as fuel in power plants. It's also improve air quality index and encourage establishment of decentralized pellet manufacturing. It's also means supply chain will be established, and many employment also will be generated if we promote this policy. So seeing the severity of this air pollution in North India only, Ministry of Power issued a policy in November 2017 that all fluidized bed and pulverized coal units, except those having, that time it was not just because NTPC in November 17 they demonstrated uh, fully just use of this biomass co-firing in their Dadri power plant, and based on their demonstration, successful demonstration, ministry issued that policy that 5 to 10% of biomass can be co-fired in the coal-based thermal power plant units. So CA was given the responsibility to develop specifications which were issued, and that time in the policy appropriate commission, it will determine the compensation to be allowed in tariff. So CERC issued accordingly. It was mentioned in the policy that increase in cost generation will not be taken into account for the purpose of merit order for dispatch of electricity. Later on, work was just moved ahead in this direction. Many committees were formed in September 2018. Preparation of technical specifications of biomass pellets for co-firing in coal-based power plants was done by CEA, and it is also available on our website. In December 19, committee was constituted under member thermal CEA to look into the methodology for arriving at rates of agro residue, and committee also submitted its report in July 20. Further, in September 20, committee was constituted under additional secretary MOP to look into the supply chain issues, and this now I will just let her tell about biomass mission also. So committee, they also have given their recommendations in November 20. Committee was constituted under chief engineer of my division, thermal engineering and technology development, to undertake research in utilization of agro residue in thermal power plants. So this committee also submitted the report, and they have finalized 13 areas of research, and that have been shared with Biomass Mission at present. Meanwhile, Ministry of New and Renewable Energy, they also issued notification in September 19 that power generated from co-firing of biomass in coal-based thermal power plants is renewable energy and is eligible for meeting non-solar renewable purchase obligation. Uh, this then in July 21, Ministry just constituted a biomass mission, and October 21 policy was revised. In the revised policy, just this biomass co-firing was made mandatory in the these mills, ball mills, ball and race mills, and ball and tube mills, and percentages also decided. All coal-based thermal power plants with bowl mills shall on annual basis mandatorily use 5% blend of biomass pellets in the first year, and the obligation shall increase to 7% with effect from 2 years after the date of issue of the policy. Similarly, in ball and race mill, torrefied pellets will be used in first year 5% co-firing, and second year onwards it will be 7%. Ball and tube mills, uh, torrefied pellets with the 5% 5% co-firing, but here seeing the volatile content because prone to fire hazards, so volatile content should be below 22% in case of ball and tube mills. Further, in the policy, generating utilities have certain units under reserve shutdown or not being dispatched due to merit order dispatch consideration would ensure to increase the percentage of co-firing up to 10% in their other operating units. So this percentage in the various mills is summarized here. In you can see bowl mills, type of pellets, it can be torrefied as well as non-torrefied. First year compliance is 5%, and second year it is 7%. Ball and race mill, it is torrefied pellets only. First year 5%, second year 7%. And ball and tube mills torrefied with volatile content below 22%. First year 5%, and research is being done in this area that we can increase the percentage in these mills, and it is also part of policy that is percentage of co-firing will be reviewed time to time. An exemption committee has also been formed as per the policy. Any power plant seeking exemption relaxation from co-firing may be considered on case-to-case basis based on the recommendations of CEA. Committees headed by Chief Engineer TETD and have member representatives from NTPC, BHEL, CPRI, Ministry of Agriculture, and Mission Directorate also. Revised policy would be in force for 25 years or till the useful life of power plant. Minimum percentage of biomass for co-firing will be reviewed time to time, as I earlier told, and minimum contract period to establish the proper supply chain. Minimum contract period for procurement of biomass pellets by generating utilities for 7 years, so as to avoid any delay in awarding contracts by generating companies, and also to build up long-term supply chain. Regarding this provisions are also related to tariff determination and scheduling. For projects set up under Section 62 of Electricity Act, the increase in cost due to co-firing of biomass pellets shall be passed through in energy charge rate, or which project, any new project is not covered under Section 63, so those will be covered under Section 63 under change in law provision. Such additional impact on energy charge rate shall not be considered in deciding merit order dispatch of the power plant, and obligated entities such as DISCOMs can meet their renewable purchase obligations by buying such generation of co-firing. major completed the ongoing activities related to revised policy, the testing methodology for paddy content in biomass pellets and identification that have been identified, framework for reporting of quantity biomass pellets. It has been developed. Biomass mission is collecting data on a daily basis, and model contract, it is under finalization. It has been already submitted in ministry, and very soon it will be shared with the utilities, and penalty clause and reward schemes also under finalization, and very soon these will be shared with the utilities. So in July, this biomass mission was found. It is a 3-tier structure. So first is steering committee headed by Secretary Power, sir. And it is further, next level is executive committee. It has headed by member thermal CEA, and mission directorate headed by executive director NTPC. So under mission directorate, we have 5 subgroups, specialized subgroups, and which are being given responsibilities, different areas. Subgroup 1 is headed by Director General CPRI. It is working on research and development on characteristics of biomass. Subgroup 2 is headed by Director Operation NTPC. It is working on research and development of boiler design for biomass co-firing and safety aspects. Subgroup 3 is headed by Additional Secretary Thermal, Ministry of Power. It is to look into the issues to resolve supply chain related issues, business development. And subgroup 4, it is being led by Director General BEE. This is to select designated labs and certification bodies for testing of biomass pellets and municipal solid waste pellets. And subgroup 5, it is headed by Joint Secretary R&R Ministry of Power. It is to look into regulatory framework and economics of biomass co-firing in coal-based plants. So this is my small presentation regarding policy. If any questions regarding policy, just let me know.
Thank you so much, sir, for your lovely presentation. That was Shri Om Kant Shukla, sir. That was a lovely presentation. Definitely, some of the people, some of the participants might be having some questions. And if you have any questions, participants, please raise those questions in the chat station. And after that, we'll move on to our panel discussion for those questions. Thank you so much, sir. And with the note, I would like to move on to our next presenter. He graduated from IIT Bhubaneswar. He joined NTPC in 2009. He worked in NTPC Rihan Thermal Power Station for 10 years, later joined NTPC Dadri. He has 13 years working experience in power plant present operation department, and he is engineer Vivek Singhal. Welcome, sir, and it's all yours with your presentation.
Thank you, sir. Is my presentation visible, sir?
Yes, 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 sir. It's visible.
Hello, everyone. Myself, Vivek Singhal. Today, I will discuss co-firing of biomass pellets in NTPC Dadri. Since biomass pellets is being fired in NTPC Dadri since last 5 years, so I will discuss the practical experience of NTPC Dadri, which we faced. What was the problems we faced initially? What was the solution? What was the modification we provided for solving these issues? These are the presentation highlights. What was the reason for using the biomass pellets? What was the NTPC Dadri experience, and way forward? Smog is very common phenomena in northern India. It is during early winter seasons, agriculture burning was there, due to which the smog increases very severely. Agriculture burning is done by the farmers after the harvest, and the smoke created due to this agriculture burning, coupled with low air velocity and the other source of pollutions, it creates a havoc in the northern India. So solution was that we burn this crop residue in the power plants in spite of the fields. So first, these crop residue needs to be converted into the biomass pellets. Then the biomass pellets will be burned into the thermal power plant. As the thermal power plants are equipped with effective dust control mechanism, so there would be no pollution if these crop residue are burned in power plants. For that purpose, NTPC Dadri was identified as the pilot project in 2017. As biomass co-firing was done in India for the first time, so there were many apprehensions about the biomass co-firing, like because our power plants are designed for the 100% coal firing, so we do not have infrastructure for biomass co-firing. So there were apprehensions whether our milling system, pulverizer system will be able to handle the biomass, whether flame quality would be good or not, whether our APH, what would be the APH performance, what would be the ESP performance, what would be the efficiency, what would be the effect of the efficiency of the boiler. So for that purpose, a team was prepared. Team was consisting members from CCOS, CC Engineering, and Netra. Netra is the NTPC's research wing. And they did some brainstorming, and they decided the specification of pellets which would be burned into the power plants. And after that, after the trial operations of these burning, we reduced the operational procedure so that 100% safety can also be followed, and we could burn the biomass also. So as a first step, we decided to co-fire 100 metric ton of pellets in one of the Dadri power plant stage 1 unit 4, which is 210 megawatt. So in the first step, we want the 5% biomass and 95% coal. In the second step, we want 7.5% and finally 10% of pellets. When the trial operation of 10% pellets and 90% coal was successful in one mill, then all the mills were fed with 10% of pellets and 90% of coal, and the mill unit was run to full load. When this trial operation was successful, then we commercialize this biomass operation. These are the technical specifications of biomass pellets. Technical specification consists of material, shape, diameter, length, GCV. As you can see, the GCV of biomass is equivalent to coal. Also we did some approximate and ultimate analysis of biomass. As you can see this in this analysis, when we are using 100% coal, then volatile material content is 22%. But in case of 100% biomass, volatile material content is 67%. It means that 3 times volatile content is there in the biomass. So when we are using the blend mixture of 90% coal and 10% biomass, then volatile material increases. So it posed a challenge for us. So how to tackle this problem? Also, we did some ultimate analysis. In the ultimate analysis, our findings were that nitrogen and sulfur contents are higher in 100% coal as compared to 100% biomass. So results were good because nitrogen and sulfur content converts into the NOx and SOx emission. So if the nitrogen and sulfur contents are reduced, then it means the NOx and SOx emission will be reduced, and it will be good for the environment. We did some combustion analysis, and the findings were that biomass samples starts devolatilization at 200 degrees centigrade. Devolatilization is the process where the volatile material starts evolving. In case of coal sample, volatile material starts evolving at 300 degrees centigrade. So there is no problem when we are using coal sample, but when we are mixing the biomass with the coal, then we cannot go beyond 200 degrees centigrade, because if we are going beyond 200 degrees centigrade, then there are chances of fire. So this was the first roadblock in the using biomass. Our overall experience was that we first biomass started firing biomass in September 2017 in 3 phases. In the first step, we fired 5% pellet and 95% coal. Then in second step, we fired 10% pellet and 90% coal. And when trial was successful in one mill, then all the mills were fired with 10% and 90% coal at full load. And based on the experience, on 4th December 2018, we commercialized the co-firing of biomass in the NTPC Dadri stage 1. Stage 1 is comprising of 210 megawatts, 4 units. So in the later, in stage 2 of Dadri power plant, which is having 500 megawatts, 2 units, we 16 January 2020, we achieved commercial biomass operation in 500 megawatt unit also. So as we know that thermal power plants are designing for handling 100% coal capacity, but initially we were not having any facilities. So the facilities were developed for handling the biomass. So from the coal handling plant area, first when the first biomass pellets were arrived at the coal handling plant, the feeding was done through the emergency hopper with the help of dozer, as you can see, and the rest of the consignment of biomass pellets feeding was done through the emergency feeder in controlled manner by adjusting rack and pinion, so that mixing can be done. In the later stages, we developed some facilities like that truck tippler system. This is a truck tippler system where biomass is received in this truck, and by using this tippler system, we are unloading all the biomass in a one go. As we are dealing with 10%, we are talking about the 10% blending of biomass. 10% of blending means that we are handling 10 tons of biomass. So we cannot achieve this manually. So we need to automate the system. So initially the system was not available. So we used the levers to empty the biomass. The blending is biomass is done from the biomass is first collected in the reclaimer hopper, and the coal is collected in the tracker hopper, and from through conveyor biomass is sent to the transfer point. Biomass and coal is sent to the transfer point. In the transfer point, there is vibratory feeders up there. Vibratory feeders mixes the coal and biomass uniformly, and from that transfer point, this mixture of coal and biomass is fed to the all the bunkers of the running units. All the bunker is the part of the mill where the coal is being fed, fuel is being fed. These are the photos of the reclaimer hopper in the coal handling plant area. In these reclaimer hopper, we unload the biomass. This is the photo of the initial phases when the biomass was unloaded manually. These are some more photos of the biomass which is being handled in the coal handling plant reclaimer hopper. This is the photo after blending of biomass and coal. This is the photo of conveyor belt. Picture is not much clear. This is the photo of conveyor belt where biomass and coal is being blended, and it is being fed from the conveyor to the bunkers of all the thermal power plant, all the bunkers. So we are burning. So we have fed the coal to the bunkers of the mill, but now we need to burn the coal in the furnace. So there were some modifications which were required, which we learned through the trial operation of the biomass. As some audience may belongs to the power plant, so they can understand easily, but I will explain. I will try to explain. This is the photo of the mill pulverizer, which pulverized the fuel. This is the photo of the bunker. Sorry, this is the photo of the bunker where the fuel is being fed. This is the feeder. This is the pulverizer. In this pulverizer, coal is being pulverized, and the fine pulverized fuel is being sent to the furnace. This is the line of the air. This is the hot air line. This hot air line, why do we use hot air? Because hot air removes any moisture content in the fuel. And this hot air also transports this fuel to the furnace. So this hot air is coming and transporting the fuel to the furnace. There are 4 corners. These are 4 corners of the furnace. The pulverizer outlet connects to the 4 corners of the furnace, and fuel is being fed. So we also use cold air, because in case if temperature is very high, then we can maintain the temperature using cold air. So this system is automated. The system is being kept in auto. We simply normally when we are using 100% coal, then the temperature is controlled by using mill outlet temperature, because we do not care much about the mill inlet temperature. But in case of biomass, as I have explained earlier, the volatile matter content is very high. We cannot go beyond 200 degrees centigrade. So we needed to provide some new interlocks and protection for using biomass. If we are using biomass, then we cannot go beyond 200 degrees. So we control the mill system by using mill inlet temperature in spite of mill outlet temperature. Also, we provided additional protection of hot air gate closing. Hot air gate from where the hot air is being fed to the pulverizer. So if the mill inlet temperature goes beyond 185 degrees, then the hot air gate will close automatically to prevent any fire. Also, we provided some modification in the mill inerting system. What is the mill inerting system? Mill inerting system is the system if in case of any fire in the mill, the fire will steam will enter to the pulverizer, and it will quench the fire. The initial original design was that there is manual valves are provided near the mill. In case of any fire, we can open that manual valve. But as you know, the chances of fire in case of using biomass is very high. So we cannot rely on the manual valve. So we did that modification. If we provided motorized control valve at the near mill, so that if in case of any fire, we can open that motorized control valve and we can quench that fire. Also, we provided orifice in mill inerting lines to reduce the steam pressure. Also, suppose if there is any localized ignition, so we cannot find it from the control room. So for that purpose, in all the 4 pipes, these are the 4 pipes which are pulverizer outlet pipe, which are going to the furnace. We provided temperature sensor point, so that temperature value will be available in the control room. And according to the temperature, the operator which is present in the control room, he can take the informed decision whether I should stop the mill or whether I should keep the mill in service in case of any localized ignition. And suppose in temperature in one pipe increases very fastly. So finally, after these trial operations, we came to the mill parameters that when we are using biomass, the mill outlet temperature should maintain around 60 to 65. Mill inlet temperature should not cross in any case 180 degrees centigrade. PA header pressure means primary air header pressure, which we are using for transporting the coal from the pulverizer to the furnace. In 100% coal, we are maintaining the primary air header pressure around 760. But in case of biomass, for being on safer side, we are maintaining it more than 800 mm water column. Also, purging of mill is mandatory. Purging is a normal process when we run the mill in unloaded condition to remove any residual fuel from the pulverizer. Also, when we are using biomass, then continuous monitoring of all the parameters, most importantly, mill inlet temperature, mill DP, because we are using low mill inlet temperature. Low inlet temperature means there are chances of moisture. So the mill current can increase, mill DP can increase. So we need to monitor all these parameters. Also, mill reject system should be kept in continuous observation. Local area, in case of biomass, local area operator, role of local area operator increases very much, because suppose biomass is being fed into the bunker. So bunker height of bunker is around 20 to 25 meters. It takes time for the biomass to reach to the feeder to pulverizer. So local area operator will see it from the feeder view glass whether the biomass is coming or not. And when the biomass starts coming, he will inform to the control room, sir, biomass has started coming. You can make biomass made on. Also, we need to maintain flue gas temperature. We need to observe all these parameters. Flue gas temperature is operator zone, APH flue gas outlet temperature. All these parameters need to be maintained. This is a log sheet which I provided, which coal handling plant provides to the operation department whenever the biomass is being fed. This is the detail of the biomass. Suppose 50 metric ton of biomass is being fed, then how much from which bunker level this feeding has been started and up to which bunker level, and what is the percentage of biomass and coal percentage. So all the data is available to the operators, so he can take an informed decision that what should be the expected time of arrival of the biomass. So whenever the biomass starts coming into the feeder, we need to make the biomass mode on. So I will explain this. This is the screen. This is the new mimic which we have provided for the biomass operation. Currently, if 100% coal is there, then we are running the mill in the biomass off mode. But suppose biomass has started coming into the feeder and operator has informed us, then we need to make biomass mode on. But because we need to reduce the mill inlet temperature, so first we will take the system in manual, and we will reduce the mill inlet temperature. This is mill inlet temperature, and when mill inlet temperature will come to the below 180 degree, then we will make biomass mode on and we will put the system in auto. When we have put the biomass mode on, then it will automatically track the mill inlet temperature in spite of mill outlet temperature. So this is and all the interlock protection and alarms related to biomass will start in action. So these are the modification I am discussing, which we have used in the NTPC Dadri plant practically. This is the procedure for changeover for biomass. I will not go in detail due to time constraint. In case of any fire during biomass co-firing, suppose any biomass co-firing chances of fire is high, and suppose fire is reported and any parameter reports that there is chances of fire, then there is standard operating procedure for quenching that fire. Only one difference is there, that in spite of manual valve, there is mill inerting motorized valve is there for quenching the fire. These are the photos of the NTPC Dadri power plant for the biomass reception, how the biomass is received and how the biomass is being unloaded here. These are the photos of the biomass storage. One problem with biomass is that it absorbs moisture very easily. So we try that whenever the biomass is received, we try to use it on the same day. When the biomass is being received, we fed it to the bunker on the same day, whichever bunker is empty. Because we have made our all 6 units with the biomass co-firing capability. So this is the storage system for now. How we are storing the biomass system, biomass storage. Thank you, sir. For any doubts, you can mail me or you can discuss now. Thank you.
Thank you so much, sir. That was a lovely presentation by our engineer Vivek Singhal. So thank you so much. Thank you so much. And we have got one question. That our question will be asked later to Mr. Vivek Singhal. We'll ask the question later, sir.
Okay, sir.
Thank you. Thank you so much. Well, today's discussion, and those who have just joined here in this participants list. So I'd like to tell you something that what are we doing right now in this webinar. Today's webinar is all about technical feasibility of coal biomass co-firing for thermal power plant organized by Engineers Welfare Forum, WBPDCL, in association with IIT ISM Dhanbad, CEA, NTPC, and National Mission on Use of Biomass. We have got our presenter here next. Would like to invite the person who graduated in mechanical engineering from Nagpur University and postgraduated from NIT Surat. He is serving in Central Power Research Institute, Bangalore since 2007. He has few research paper publications on residual life assessment of boilers and analysis and testing of transmission line conductors and its accessories in national and international conferences. He has been nominated as a member of National Mission on the Use of Biomass in Thermal Power Plants in October 2021 and presently contributing as a member in the National Mission for the Implementation on the Use of Agro Residue MSW Biomass Pellet in Thermal Power Plants. And he is our very own Prafulla Chandra Dongre. Welcome to the board, sir. So you have to unmute your device.
Yeah. So good morning, all of you, and good morning, all the dignitaries there. Hope I'm audible to everybody.
Yes, sir, you're audible. I think your presentation will be presented from our side, from a host side, I think.
Yeah, please.
So if you want to change this slide, I'd like to request, please send next slide so that our host can change the slide to the next one.
Okay. Can I do one thing? I will just try from my side whether it is possible to share the screen, or if not, means you can share. Is it okay?
Fine. If you want to try it from your side, definitely it's okay.
Yeah.
So I request my host to please switch off the screen share so that Sri Prafulla Dongre sir can share the slide. So if you want to try, you can try from your side.
Yeah.
So that
Yeah. Is it visible?
Yes, sir, it is visible. If you just check whether the slides are changing or not.
Yes. I think the problem is still there. Okay, fine. You please share from your side. That will be good.
I'll request the host laptop to please share the screen from your side. And before moving to the presentation, there is a lucky draw for all the participants, those who are participating in this webinar. So we have got a lucky draw at the end, and one lucky winner or more than one lucky winners can win some lovely prizes from Engineers Welfare Forum WBPDCL. So it's your slide, sir. It's Prafulla Chandra Dongre, sir. It's your slide. If you want to change the slide, just say next slide and it will get changed.
Yeah, fine, very fine. Okay. So friends, today's my topic of presentation is based on biomass co-firing with coal, its impacts, guidelines, policies, and future prospects. That is like a future roadmap as well, because I am representing National Mission on Use of Biomass in Thermal Power Plants. Okay, next slide, please. Okay, yeah. So during the last decade, India has been experiencing severe pollution, and the reasons may be many. But stubble burning due to crop residue has been one of the major cause of air pollution in the country, particularly in the northern states, mainly Punjab, Haryana, and UP, which are contributing in burning to an estimated of around 35 to 40 million tons of crop residue in their paddy fields. The reasons for this are different and many, but the primary reason is to reduce the turnaround time between rice harvesting and sowing for next winter crops. And secondly, to reduce the cost of clearing the fields. And also, what there are few lack of alternative methods of agriculture implements to take out these complete stubble from the field. Because when our farmers are taking out the stubble, always there will be like 3 to 4 inches of residues are still there. So they are find much more easy to burn it. Next slide, please. So as you are known that stubble burning is one of the contributor to atmospheric pollution. It releases toxic pollutants and other harmful gases like carbon monoxide, methane, volatile organic compounds. And these pollutants and particulates generally of PM 2.5 and PM 10 as well, not only affects the air quality, but degrades human health also. And moreover, the heat generated that penetrates into the soil causing an erosion, which are definitely loss of useful microbes and bacteria, which are useful to the soil, and it also kills the bacteria which affects the soil fertility. Next, please. So, a report by United Nations in 2015 pointed out that the world population may rise to 10 billion by 2050, and which eventually will turn increase in food demand. And if we see from Indian point of view, by 2050, the crop production is likely to increase by more than 45% or so. That is, from 2017, the 619 million tons of crop, which has to be required by 2050, around more than almost 900 million tons. So there is a huge increase of food demand, which will necessitate the more production of food, and consequently, it may happen the chances of burning more stubble. So by considering such kind of things and further, in order to reduce stubble burning and to reduce carbon footprints of thermal power plants, Government of India, Ministry of Power has taken various proactive steps, and in this direction also set up a national mission on use of biomass in thermal power plants. So, and they have set up policy guidelines which was issued in October 21, which are already started showing some good results by the utilization of biomass in thermal power plants. And with this, the farmers will also get an income apart from the waste stubble. So this is like a win-win situation. And if it is very much to say that the current availability of biomass in India is almost, in fact, it is more than 700 million metric tons per year. And the study indicated an estimated surplus biomass availability at about 230 million metric tons per annum, which has a potential to generate of about 28 gigawatts. So there is a huge availability of biomass. And if we consider even 5%, which is as per policy as presently, so 700 million metric tons of coal per year, that is 35 million metric tons of surplus biomass is available. So this will help in solving the problem of stubble burning as well as producing electricity with the renewable source. Next, please. So with this, as our government has set up, Ministry of Power has set up a mission, which has a three-tier structure, which my colleagues has already stated, which is consist of a steering committee headed by Secretary Power, executive committee headed by member Thermal CEA, and then mission director headed by executive director NTPC. And further, there are 5 subgroups, specialized subgroups, which are looking at various specialized works, like subgroup 1, which is headed by DG CPRI, working on research and properties of biomass. Subgroup 2, headed by NTPC, looking on the technical specifications and safety aspects. Subgroup 3, headed by MOP, which is looking after supply chain and logistics and business development. Subgroup 4, headed by BEE, basically involves in preparation of standards and certification and identification of the labs. Subgroup 5, again headed by MOP, which are looking after regulatory framework of biomass co-firing. Next, please. Yeah. Now, as a national mission on biomass, what are the mission objectives? The mission objective, as per the guidelines, is to increase from present 5% to higher levels. Of course, the larger thermal share, we want to increase the biomass in power plants and to take up R&D activities, because if the larger thermal share are increasing, definitely there will be a change in boiler design in future if it goes more than 15% and more than 20% or so. To address the supply chain of biomass pellets and agro residue and training of the personals at the different stakeholders to resolve regulatory issues in biomass co-firing, and to formulate a mechanism to provide capital financing to encourage our entrepreneurs or the upcoming entrepreneurs and and to identify critically needed infrastructure and to encourage the government stakeholders to sensitize all the stakeholders like ministries, departments, state governments, farmers, local bodies and agencies, etc. And preparation of guidelines, release of RFQ, RFP, and signing MOUs, and so on. Next, please. So there are revised policies which has been issued on 8th of October 2021, which basically mandates in bowl mill 5% blend of biomass with effect from 1 year, then after 7% biomass co-firing with effect from 2 years from the date of issue of guidelines, and for in ball and rice mill, again 5% blend for torrefied only with effect from 1 year from the date of issue of these guidelines, and 7% after 2 years. In ball and tube mill, 5% blend of torrefied pellets with volatile content of below 22%, considering safety aspects. And if and there are certain units in generating utilities which are under reserve shutdown, which has and are not being dispatched due to MOD. So there is a consideration of percentage of co-firing up to 10% in their operating units. Next, please. So these complying policies means are also if any power plants are seeking exemption or relaxation. So MOP has made some committee based on the recommendations, which will decide based on the recommendations of CEA headed by committee CEA, TET, and D, which will be headed by CE of CEA, and including other representatives of NTPCs, BHEL, CPRI, Ministry of Agriculture, and Mission Directorate. So this policy is particularly in force for 25 years or till the useful life of thermal power plants, whichever is earlier. And this Electricity Act under Section 62, 63 has been explained by my colleague Shri Omkant Shukla sir. So I won't discuss these things. Please, next slide, please. So these policies definitely will contribute to the National Clean Air Program, and it would further support the energy transition in the country and fulfill the targets to move towards cleaner energy sources and helps in reducing carbon footprints of coal-fired thermal power plants. So this methodology or these policies are also applicable for captive power plants using co-firing of biomass. Next, please. Now, as I've explained in my previous, there is a lot of market potential for the usage of this biomass, because quantum of biomass resource available in India, which is sufficiently can take up these policy guidelines presently of 5%, 7%, and 10%, and which is going to be reviewed from time to time, of course, by using using and increasing the thermal share in the biomass. Now, presently, availability of biomass in India is around 700 to 750 million metric tons, and the surplus is 230, which has a potential of 28 gigawatts. And in this regard, NTPC has executed a tender of to procure 20 million tons of biomass, which will enable the firm to co-fire pellets at its power plants, and which are in the process also. And not only these are limited to power plants, other industries like cement, FMCG, pharmaceuticals, etc., are also need to be consumed this biomass to meet their individual goals on emissions, because this is a collective responsibility of all the stakeholders to to reduce the greenhouse gases and to contribute in the clean air. Next slide, please. So in this regard, a national mission on biomass has drafted some few model contracts, which is under finalization stage and which will be issued shortly, which is addressing the concerns of pellet manufacturers, GenCos, and which gives a common standard guideline for promoting the biomass, which has a long-term contract. The period of contract shall be for 7 years, and there is a price adjustment of gross calorific value, and which has a definite guaranteed parameters. I think your font has been changed. I don't know how. And there are rejection level if it has a moisture of more than 14%, and if any non-serious bidders are there, so they have to deposit security deposit as per the guidelines, which is a minimum of 25% of the total security deposit. Can we move on the next slide, please? And of course, if the price variation clause, if the supply is not on the actual destination or in some other place because of certain reasons, so the price variation clause is also there, depends on the labor, diesel, and electricity usage. The mission has also identified technical specifications for agro-residue based pellets, which are there in terms of bulk density, moisture content, and GCV. And yes, is it audible? Excuse me.
Yes, sir. Yes, sir. It's audible. It's audible,
yeah,
sir.
fine, because some disturbances were there. Okay, so the contracts will have a certain periods and delivery schedule, and these are going to be issued shortly, which will also create an additional income to our farmers. Next, please. So action carried out by the mission. So apart from being, because these missions is actually working within a short period of time, the mission has done a lot of good things, and it has to be spread and implemented across pan-India. So, so what are the basic things what we have done in this is, we have made a model contract for procurement of biomass, which is under finalization stage, and there are also made up an exemption for the guidelines, which are doing under the head by CEA, and there are technical assistance also being given, and SOPs has been prepared and issued to all TPPs for their references, and their issues and concerns raised by GenCos on biomass co-firing has been addressed. Day-to-day monitoring is being done on regular basis for the biomass usage, and a lot of database and vendor database is being developed. And in that one, 8 NABL labs have already been identified, and the list has been circulated. So apart from these IS standards, which is presently not available for exclusive for biomass usage and testing, so that is also being taken care by one of our subgroups. And R&D activities due to long storage of biomass, so how the loss of GCV is going to affect its efficiency in during the firing, that has to be taken care, because as you know, the harvesting is between 2 to 3 months only. So another, if for a continue longer period, if you want to use those biomass, so what will be the effect on the GCV if there is a longer duration of storage? So that also has been taken care by one of our subgroup 1. And definitely to spread this activity, to spread the mission across pan India, we have to be go on training and awareness campaign, which is being done to give training to our GenCos and pellet manufacturers, awareness to our farmers. So these are being carried out by our mission. Next slide, please. Yes, so the farmers awareness campaign has been carried out, like 2 numbers of farmers awareness campaign has been conducted at NPTI Faridabad and Nangal for sensitizing the farmers regarding the consumed use of agro residue. A total of 65 farmers participated in Faridabad from various districts of Haryana and Uttar Pradesh on 8th of October 21, and a total of 72 farmers participated in Nangal from various districts of Punjab and Himachal Pradesh on 21st of October. So these are very much important to make them aware how to use their waste stubble and generate the income. Next slide, please. Yeah. So now this progress in co-firing our biomass in TPPs. Now already there is usage of biomass in TPPs. This is up to the last month of data up to the 22nd of February. In NCR region, power plants, NTPC power plants has usage of 20,995 metric tons. And apart from NTPC, other groups like 714 metric tons, they have used it. And other than NCR regions, 42,561 metric tons of biomass has been used, and in other power plants, 113 metric tons has been used so far. So a total biomass usage of 63,491 metric tons has been used so far. It's still going on. This is a still it is under progress. Next slide, please. So tender has also been implemented in NCR region of NTPC power plants. It is the tender has been awarded a total. It is awarded and under award and under tendering stage. So total of 40,93,200 metric tons. And in other power plants, it is 2,22,800 metric tons. And in other region, apart from any other region of NTPCs, it is 65,55,800 metric tons. And in other organization power plants, it is 35,69,785 metric tons. Next slide, please. So in addition to this, national mission has our separate website, which is going to be launched very shortly under the name of SAMARTH, which is a sustainable agrarian mission on agro residue use in thermal power plants. So it is this platform will definitely gives an interaction for all the stakeholders, that is farmers, pellet manufacturers, and GenCos. So it has it has a lot of users interface, and how to use this biomass and all. It will be interacted in this platform. Next slide, please. So there are silent features for our GenCos also. Vendor database has been created and being updated on regular basis for GenCos, which can be accessed on mission website. And another salient features in the next slide, it will be there. Next slide, please. The following features will be enabled for nodal officers for biomass reporting, because day-to-day reporting, how much is the biomass usage in the power plants, it is being taken care. So under this, that like a tender detail management, actual consumption management, and consumption forecast management, and pellet costing management under management information system, actual consumption report, tender detail report, costing report, and forecast report. Everything will be available, and proper addressing will be taken care to all the stakeholders. Next slide, please. So the prominent mission achievements are still it is under process, and it is under achievement stage also. So the revised policy for mandatory biomass co-firing in all TPPs has been issued by MOP on 8th of October, and 8 enable labs have been identified as per ASTM standards, where the list has been circulated to all the GenCos. Day-to-day reporting and monitoring is being done on regular basis for biomass usage, and issuance of model contract for procurement of biomass pellets is on the way, and guidelines has been finalized for exemptions as well. Next slide, please. So vendor database has been developed for facilitating the biomass supply chain, and a framework for online updation, reporting, and monitoring has been developed through this mission website. And due to storage, loss of GCV is being taken care in our R&D activities, and various farmer awareness program, training activities, pallet manufacturers, for pallet manufacturers and GenCos is being going on, and to spread and implement across pan-India newspaper advertisements, hoardings in different states has been taken care by our mission, and it is being going on. Yeah, next please. So what is the future prospects or the future roadmap? Now we are using the power plants are using 5%, 7%, and may after due revision, and also it may increase to 10% or so. So definitely there will be a requirement of technological firing, like direct firing, parallel firing, and indirect firing. So presently, direct firing is going on. So how to go in terms of that if the thermal share increases, and what are the changes in the design of the boiler and all? It is to be a matter of concern, and actually it has to be addressed when the thermal share increases. And not only that, how to use the torrefied biomass in co-firing, and for that how the torrefaction technology has to be implemented and used in a mass scale. So that is also to be addressed in future. And next one is preparation of Indian standards, because exclusive for biomass usage, Indian standards are presently not there, because there are different regions where the biomass, where the wet stubble is, where the stubble is being used or is being used for biomass. So they have their different characteristics, because the soil characteristics are different from region wise. So that has to be addressed in due course. And research methodology is also been initiated by the mission with the relevant subgroups. And the research and development areas are required for agro-residue fuels in terms of chlorine and alkali content, biomass, fly ash in cement-based materials, volatile metals in biomass with coal, and other related issues is being initiated and is being under a process. So thus, not only GenCos and not only all the stakeholders, all people of India have a major role in implementation of policy guidelines issued by Ministry of Power, Government of India, because these only can thereby helps in reducing greenhouse gases and low carbon footprints with the active participation of power plant utilities, farmers of this country. So this will be a win-win situation to all the stakeholders, especially to our farmers, which will generate additional income to them as well. So by utilizing and implementing these policies in a proper way, definitely we are going to contribute in the clean air program, and ultimately we will try to reduce the greenhouse gas emission and to neutralize or to reduce the carbon footprints of the thermal power plants. Next slide. Yeah. So this is up to this one. Any queries and all, you can contact with those email ID. Thank you very much.
Thank you so much, sir. That was Shri Praful R. Dongre, Engineer Officer, CPRI, and member of National Mission on Use of Biomass. Thank you so much. Thank you so much, sir, for your lovely presentation. And next, without wasting any time, I'd like to introduce our next person, but not as a presenter, because he is a guest of honor of this lovely webinar. He has completed his education in BTech Chemical Engineering from IIT Madras. Presently, he is Additional Chief Secretary, Power Department, West Bengal. He has been impaneled for holding Additional Secretary AS level post or equivalent post at Government of India. So with allowed here, it's an immense pleasure that we have got this lovely person with us here in this lovely webinar. He is none other than Shri S. Suresh Kumar, IAS. Welcome, sir. Sir, I think you are mute now. You have to unmute.
Right. Okay, I'd like to thank you very much, and I would like to congratulate the Engineers Welfare Forum for organizing this webinar. It's done at a very right time. In fact, Government of India, Ministry of Power has already given a circular asking us to implement the 5% 5% of the biomass in with coal to be added to the coal for firing in all the power plants, and from the 1st of April. So I think I hope everyone has understood what are the implications and how it should be done. From our side, I think I have pushed our West Bengal Power Development Corporation to study the pilot project which has been done at NTPC Dadri, and Mr. Singhal has, I think, very nicely elucidated the whole issue related to use of biomass there. So we already have quite a few people showing interest and about securing us the biomass, which is going to be very critical now for use. I hope that we get our act together about using more biomass, and one of the major sources other than the paddy stock is the sawmills which are run by the state government all over the state, and supplies of biomass can be also secured from there. So I wish that everyone implements the ideas which have come up here, and we are able to put in this directive regarding use of biomass in our power plants also in use. Thank you very much, and good day.
Thank you so much, sir. Thank you so much for your love. Thank you so much for your lovely speech. That was Sri S. Suresh Kumar, IAS. Thank you. Thank you so much, sir. Well, moving to our next presenter of this lovely webinar and this lovely Sunday. But before that, I'd like to announce one thing again to all the participating here in this lovely webinar. We have got a lucky draw at the end of this webinar. So one or more than one participant might win a lucky prize through a lucky draw contest. So I request everyone to please stay bound to this webinar, because at the end, if you miss your prize. So now moving to our next presenter here, but before that, it's a technical feasibility of coal biomass co-firing for thermal power plant organized by Engineers Welfare Forum, WBPDCL, in association with IIT ISM Dhanbad, CEA, NTPC, and National Mission on Use of Biomass. And the webinar is currently going on. We have got our next presenter on board. He is a research scholar from IIT ISM Dhanbad, and it's time for Sri Shubhojit Aich, sir. It's all yours.
Am I audible?
Yes, sir. You are audible, sir.
Thank you. Hello? I'm audible? Yes.
Yes, sir. You are audible, sir.
Thank you. A very good afternoon to all the respected panel members present in today's virtual webinar. Hello, myself Shubhojit Aich, a research scholar from the Department of Fuel, Minerals and Metallurgical Engineering, IIT ISM Dhanbad. First of all, I would like to thank Engineers Welfare Forum, WBPDCL, and IIT ISM Dhanbad for giving me this wonderful opportunity to present my case study on the topic co-combustion study of coal biomass blends in TGA. So without wasting much time, I would directly come to the objective of the study, which says blending of different high ash Indian coal with various biomasses and biochars. This is the experimental process that is carried out during combustion experiment at IIT ISM laboratory. Initially, for experimental analysis, around 500 kg of run-of-mine coal was collected from different mines of Jharia coalfield in Jharkhand, India, and was used to prepare a reject coal sample of specific gravity more than 1.9 and less than 2.1 by standard sink and float test in the ISM laboratory. Sink float test is a test to separate coal based on their specific gravity in a heavy liquid medium. Similarly, biomass was collected around 20 to 25 kg of various mature tree leaves such as shal leaves, eucalyptus leaves, shagun leaves, and rice straw from different forest sources and rice mills located in the state of West Bengal and Jharkhand in India. After collecting, the biomass material were sorted with foreign materials such as dust and rock particles which are associated with the leaves. Then it is washed in tap water and dried at 60 degrees centigrade for 24 hours in an air oven to remove the surface moisture. Subsequently, the leaves were then shredded and grounded to minus 212 micron size or minus 72 mesh size in a laboratory mixer grinder to prepare a biomass powder prior to combustion experiment. Further, biochars were prepared by heating around 2 kg of this ground biomass leaves at 350 degrees centigrade for 5 hours in a stainless steel reactor in the absence of air. For blending purpose, we have taken 100 gram each of biomass coal and biochar coal mixture in different mass ratios and were prepared using a laboratory blender. Thereafter, combustion studies on coal, biomass, and biochar and their different blends were carried out in a thermogravimetric analyzer from room temperature to 700 degrees centigrade at a heating rate of 10 degree per minute under oxygen atmosphere. So this is the experimental process that has been carried at lab scale in our laboratory. Moving on to the next slide, characterization of coal and biomass. Here, the characterization table is broadly classified into 3 categories. 3 categories. First is the high ash coal whose ash percentage is more than 55% for both the coals. Second category is the forest waste where we have considered shal leaves, eucalyptus leaves and shagun leaves. In the third category, we have the agricultural waste, which is the rice straw. From table, it can be seen that both the coals having high ash of more than 55%. Similarly, volatile matter content of these coals are lower, below 17%. The second category of fuels, there are tree leaves whose ash percentage is lower, but with high volatile matter content. High VM content in this biomass helps for easy ignition, but poor stable combustion. Whereas for the chars, that is shal leaves char, eucalyptus char and shagun leaves char, we can see that VM content is comparatively lower than raw biomass, but with high fixed carbon content, which may help in stable combustion process at the end. Similarly, for rice straw, we can see that for rice straw, it has high VM content, whereas for rice straw char, it has high fixed carbon content. So rice straw will help in easy ignition and rice straw char will help in stable combustion at higher temperature process. Next, I'll move on to the slide where we have made a comparison of GCV of different selected fuels. Here, we have taken one coal whose GCV is around 3,105 kilocalorie per kg. Shal leaves char, eucalyptus char. For the shal biomasses, we see that the GCV is above 7,000 for both the biomasses. Whereas for shal leaves char, the GCV is comparatively lower. Lower value of GCV in biochar is due to removal of volatile matter content and carbonaceous hydrocarbon during low temperature carbonization process. Similarly, for the blend case, we see that as shal leaves is blended with coal in different ratios, the GCV of the blend increases, as GCV is an additive property mentioned in this by Sir. So we can see that considering the design criteria of boiler in thermal power plants for good combustion process, a GCV of 4,000 is considered optimum GCV. So here we can see that addition of 20% of shal leaves to coal reaches the GCV at 4,250, which is quite similar to the design criteria of the boiler. Similarly, for Charles Leaf's chart, we can see that the GCV of 4,000 is reached when Charles Leaf's chart added in blend is by 50%. Similar results are also observed for eucalyptus leaves and eucalyptus leaves chart. So overall, we can conclude from the slide that optimum blending percentage for biomass are around 20%, and for biochars it is around 50%. Following slide shows the GCV of another set of fuels where we have taken coal B and shagun leaves, rice straw, and their respective chars. Here also we observe that the raw biomass is having more than 5,000 GCV, whereas the char, they have comparatively lower GCV. Rest of the values, as you note, are quite similar to the previous slide with a slight variation in result, but similar. So I won't go through in detail and move on to the next slide. The following slide shows the burning profile behavior of coal, rice straw, and their blends. Figure A, the left-hand side plot shows the variation of mass loss with respect to temperature, whereas figure B shows the derivative thermogravimetric mass loss per percentage per minute with respect to temperature. In both the cases, we see that as we increase the temperature, there is an increase in mass loss percentage of the fuel. From this TGA profile, we can see that for coal, mass loss is taking place at a much higher temperature. As we add rice straw in blend in 10%, 20%, this mass loss increases and the curve shifts more towards the left side, which indicates that the blended fuel burn at a much lower temperature and provides the necessary energy required for char combustion process. For most of the fuels, after 450 degrees centigrade, the curve straightens, signifying the end of combustion process. From figure B, we can identify the different burning profile temperatures which are mentioned in the next slide. This is the burning profile temperature obtained for blend of coal B with rice straw. You can see that there are three burning profile temperature: the ignition temperature, peak temperature, and burnout temperature. For coal B, the ignition temperature, peak temperature, and burnout temperature are quite high as compared to rice straw. When we blend rice straw with coal B, the ignition temperature reduces initially from 417 to 410 degrees. With further addition of 20% biomass in blend, we see there is a huge decrease in ignition temperature. So, therefore, considering the boiler design criteria, which should match similar to the burning temperature of coal, 10% addition of rice straw can be considered as an optimum blend ratio. Such reduction in this ignition temperature can be ascribed to presence of high volatile organic matter which are present in biomass and biochar materials. Moving on to the next slide. Combustion efficiency plays a very important role in efficient utilization of biomass coal and biochar coal blend in thermal utilities. Figure A shows the blend of coal A with Charles leaves and Charles leaves char. We see that when only coal is burnt, combustion percentage is very near to zero. As we add a Charles leaves by 10%, combustion percentage improves to around 30%. This area is indicated by a circle green in color. So we can say that keeping the design criteria of the boiler in mind, it can be said that up to 10 to 15% addition of biomass and biochar can be easily mixed with coal, where the deviation compared to coal may be negligible, but if it is blended with higher percentage of biomass, significant improvement is observed, but which may not be the possible design criteria. Similar observations are noted for eucalyptus leaves and eucalyptus leaves char. So overall, we can say that blending with biomass, biochar increases the combustion percentage of coal. So here is a similar set of result again, but for different biomass with a slight variation. So I'm not going again further into the detail. Moving to the next slide. So this is the chemical analysis of coal ash and char leaves ash done from XRF analysis. From the table, we can see that coal having higher percentage of silica, 63%, and aluminum oxide of 27%, which contributes more than 90%, 91% of the total ash quantities. On the other hand, we can see that char leaves ash is mainly dominated by calcium oxide and magnesium oxide, which if present in higher quantities may act as a catalyst and support the fixed carbon ignition during combustion process. This is the summary. So here we can conclude that GCV obtained for different biomass is above 5,500 kilocalorie per kg, whereas for biochar it is comparatively lower. This is due to release of volatile matter and carbonaceous content during low temperature carbonization process. Combustion percentage improves with addition of biomass and biochar. TGA profile shows better improvement in burning profile temperatures with addition of biomass and biochar to coal. From overall experimental analysis, it can be concluded that addition of up to 10 to 12% of biomass and biochar in blend can be considered as optimum blend ratio based on other properties and design criteria of the boiler. Major beneficiaries from this mission of using biomass in thermal power plants are the coal sector, forestry, the power producers mainly, the rural community. Obviously, pollution control will be controlled in a large way, and definitely the organic liquid sector. Thank you. Thank you so much. Any queries, please? Sector, forestry, power producers mainly.
Thank you so much, sir. That was a lovely presentation by research scholar IIT ISM Dhanbad, Sri Shubhojit Aik, sir. Thank you. Thank you so much. And definitely, if you have any questions, the participants, those who are watching this lovely webinar, if you have any questions regarding our topic, definitely you can raise those questions on the chat option. So after the presentation, we'll move on to our panel discussion with your questions. And if you have any questions to a particular designated person, so definitely you can write the name also who you want to convey the questions, or to whom you want to ask the question. So next, moving to our next presenter of this lovely webinar, we have got research scholar IIT ISM Dhanbad, Sri Pritam Kumar sir. It's all yours.
Thank you. My presentation is visual?
Yes, sir, it's visible. And you are audible too.
Okay. Good afternoon, everyone. I am Pritam Kumar. Here I will present a case study on combustion of coal, petroleum coke, and biomass techniques. And this is the experimental flow sheet. Coal, petroleum coke, and biomass samples were collected, and after collection, samples were prepared into required site. And after that, combustion experiments were done using TGA. After TGA, burning profiles were obtained and combustion efficiency profiles were obtained. And individual fuels were characterized using proximate analysis, visibility determination, and XRF analysis. This is the properties of different samples, and coal having very high ash content and GCV is lower. For petroleum coke, ash and VM is limited, whereas fixed carbon is higher and GCV is also very higher. But main restriction is sulfur. Sulfur is very high in petroleum coke, but we can use it in limited amount during blending. Rice husk having high ash content and mustard husk having intermediate ash content. And among all samples, GCV of rice husk is very high, and it is more than 4,500, and mustard husk GCV is minimum. And for all biomass sample, volatile matter is very higher, and it is more than 70%. This is the GCV comparison table. And from table, we can see that after addition of 10% petroleum coke and 10% wheat straw, GCV increased from 3722 to 4270. but further increase in wheat straw not increase GCP so much. Similar observation were seen for wheat husk plants and mustard husk plants. This is the TGA DTG profile of individual fields, and from this graph we can see that rapid mass loss occurred for wheat straw, which is due to availability of high volatile metal. However, mass loss in coal and petroleum coke starts later due to scarcity of VM, signifying inferior ignition characteristics. Coal and petroleum coke showing single DTG peak due to fixed carbon combustion. However, wheat straw is showing multiple peaks due to VM combustion and fixed carbon combustion. This is the TGA DTG profile of wheat straw blends. And from TGA curve, we can see that when wheat straw content increases from 10 to 30%, then mass loss profile shifts to leftward side, signifying improvement in ignition behavior. However, from DTG curve, we can see that for 10% wheat straw, its combustion profile is similar to coal combustion profile. And for higher wheat straw content, combustion profile shows 2 DTGP, which is not our requirement as per design of power plant. From TGA DTG analysis, we obtained burning profiles. And from burning profile characteristics, we can see that wheat straw having lower ignition temperature and lower burnout temperature. However, pet coke and wheat straw having higher combustion rate. Higher combustion rate may damage boiler tube due to diffusion of ash. However, with increase in wheat straw content in blend, ignition temperature reduces and DTG mix increases for first peak and decreases for second peak. However, insignificant variation occur in burnout temperature. Overall, from this analysis, we can say that 80-10-10 ratio may be used in power plants because its burning profile is almost similar to coal. This is the combustion efficiency profile of rice husk plants and wheat straw plants. This combustion efficiency was obtained at 450 degrees Celsius. And from graph, we can see that rice husk having higher combustion efficiency compared to coal and petroleum coke, and petroleum coke having lower combustion efficiency. However, with the addition of rice husk blends, combustion efficiency increases from 52% to 62%. And for wheat straw, combustion efficiency improves from 51% to 63%. Such observation is also seen for wheat husk blends and mustard husk blends. In mustard husk and wheat husk blends, combustion efficiency is higher compared to coal and petroleum coke. However, addition of such samples in blends, combustion efficiency gradually increases. This is the deposition behavior of coal, petroleum coke, wheat straw, and their blends. And from table, we can see that deposition behavior of petroleum coke is very higher compared to permissible limit. However, for wheat straw, deposition behavior is intermediate. And for blends, it is within the permissible limit. Overall, we can say that petroleum coke having very high energy density compared to coal and biomass. However, biomass having higher volatile matter and acceptable slagging behavior. Analysis of burning profiles shows that addition of biomass improved ignition property and combustion efficiency also increases due to volatile matter and hydrogen in blends. Result obtained from GCB slagging characteristics, sulfur emission, and burning profile shows that 80-10-10 ratio of coal, pet coke, and biomass may be used in thermal power plants. Overall, current work shows that addition of pet coke with coal is helpful to improve GCB value, while blending of biomass improved the slagging, ignition, and combustion behavior of blends. Thank you. Any queries?
Thank you so much, sir. That was a lovely presentation by research scholar IIT ISM Dhanbad, Sri Pritam Kumar, sir. Thank you so much. Thank you so much for your lovely presentation. And definitely, if you have any question, again, I'm asking this to all the participants. If you have any question, you can raise those questions in the chat option, where I'll convey the question to the designated person. And if you are watching this lovely webinar, please stay together, because at the end of the webinar, we are going to have a lucky draw contest where more than one participants might win some lovely prizes from Engineers Welfare Forum WBPDCL. And moving to our next presenter here in my list, last but not the least, here in this lovely webinar, we have got a person who is a professor Exactly. He's a professor, is a British Commonwealth Fellow, and has about 40 years of experience in teaching and research, consultancy, and continuing education. He has authored a monograph, edited a proceeding, contributed a chapter each in 3 books, and has carried out 15 research and 50 major consultancy projects. He has been honored among others with National Mineral Award of the Government of India and Coal Beneficiation Award of the Indian Institute of Mineral Engineers. He is a member of the editorial board of International Journal of Coal Preparation and Utilization since the year 2004. And here our presenter next, Dr. Shumantro Bhattacharya, Professor, IIT ISM, Dharmad.
Start the video, Kunal.
We'll start with the video.
Because I have unmuted myself.
Do you have any video, sir?
No. I just want to share this.
Okay, just share the screen, sir. It will come on board. So, whatever you are sharing on the screen, it's visible now.
It's visible.
It's visible, sir.
But now it shows me screen sharing has stopped as the shared window is closed. Now, just a minute, let me see.
So you are visible on screen now, sir.
Is it okay?
Yeah, it's visible, sir. It's visible right now.
Yeah. How did we begin our research on co-firing? This is what I just wanted to share with you and raise a few issues about the future commercial application. A little bit background. Since the beginning of this particular millennium, across the research laboratories and universities, combustion research had been declining steadily. Notwithstanding the massive expansion of coal-fired power plants in India. As if all our combustion issues have been sorted out and everything is fine, no difficulty in any power plants. Given the high ash content, low to moderate GCV of our coal, there are hardly few plants which get from one particular source. Essentially, it is multiple source linked to the plant. And that linkage is not forever, it changes. Naturally, all these issues are bound to bring up combustion related issues. How to burn, single source, multiple source, how to blend. Stockpiling is another major issue. The moment you have super thermal power plants, given the daily feed rate requirement, parallel to that, the last 2-3 decades, massive accumulation of coal washer rejects took place. It went into millions and millions and millions of tons. In Jharia coalfield, in Bokaro coalfield, in some of the western coalfields area. What are these regions? These are 2000 to 3000 kilocalorie per kg GCV. 2000 is not very far from the actual run-of-mine coal being charged. Rapidly growing geopolitics on emission, India became a target, India and China. And parallelly, Europe, since the beginning of the millennium, became very serious in commercial application of biomass-derived energy. Our department is internationally acclaimed for long as a coal research center in India. And the department is a knowledge bank in coal cleaning, carbonization, and combustion. There is hardly any operator in coal sector for whom we did not work. Government agencies, public sector, private sector. For nearly 5 decades, we offered the only MTech program in fuel engineering in India. So moving into biomass combustion and carbonization research about a decade ago, kind of natural forward step, notwithstanding the constraint of research gap and drought of researchers. Very difficult to get people, even now, to work in this particular area. People have been working for last 3 decades on carbon sequestration, no visible immediate effect. Whereas burning issues of coal combustion in India, many such issues remain, many such questions remain unsolved. And yet, we don't get good people. Very difficult. But we had doubts about the supply chain of biomass. What will be the supply chain? The catalyst was my frequent self-driven weekend tours to the forests of South Bengal and Borun's familiarity with rural Bankura district, also of South Bengal. What we found that hundreds and hundreds of tons of fallen sun leaves are lying in the forest at least twice to a prolonged season in a year. And these fallen sun leaves remain in the forest with a powerful tendency towards spontaneous combustion and quite commonly causing forest fire. And they remain even after the local villagers have collected truckloads of sun leaves for their domestic cooking. And throughout the whole year, use the sun leaves for their entire domestic cooking. Even many roadside eateries in this forest and adjoining areas of Jharkhand, West Bengal, Odisha, Chhattisgarh, they use these fallen sun leaves. Simultaneously, after 2000, after the present government in its first term took charge, when in large scale gas cylinders were introduced in rural India, many households, rural households, even those who had some economic difficulties, even they tried to switch over to this so-called gas cylinders for their domestic cooking. As a result, accumulation of sun leaves kept on growing in the forest. And then we had almost an hour-long discussion with North Bankura District Forest Officer and District Agricultural Officer, Birbhum, about 10 years back. And that convinced me about the possibility of creating, maintaining, and sustaining supply chain of fallen sun leaves and crop residues from the rice fields. And that can be done, possibly commercial co-firing will be feasible with benefits to everyone, including socio-economic benefits to the rural population who will be engaged in possibly the source component of the supply chain. So then we began food stream research, taking into account the accumulation of highest coal rejects, washery rejects, and whatever we have achieved so far in our research, in a very summary form, Borun, Shubhajit and Pritam have presented. But few issues still remain. Because throughout today's presentation and through all the documentation which have been shared, it is evident that so far the thrust had been wood pellets. And that has been successfully used in Dadri, that we knew when we worked with NTPC some years back. And therefore, naturally, the Government of India wants other power plants to follow the model. That is fine, but question is, since these 4-5 states have such an abundance of sun leaves with high VM, reasonably good GCD, then why not to use this biomass for co-firing? Question is, what will be the size of the fallen sun leaves or rice straw or paddy residues, paddy field residues to be co-fired? Does it need to be pelletized or agglomerated? Suppose if it is in the size less than 2, 4 or 6 millimeter, sir, the size, better is the economy. How that size would be achieved? Shredding, crushing, pulverizing, or a combination of these? With the biomass, such biomass, not wooden pellets, will the biomass be co-fed to the mill burners? For example, a 2 millimeter shredded release or even 6 millimeter may be difficult to feed along with coal by open conveyor belt up to the mill burner feeding point. Is it possible to feed it directly to the burner? Is biomass agglomeration essential for feeding purpose? If you do agglomeration, you raise the cost. Alternately, can the biomass be the source of auxiliary fuel support as a kind of import substitute? So these are the thoughts I felt I should share with this forum, because you are the real plant operators and it is you who are already doing a bit, and as I could understand from today's deliberations, throughout the whole country this will be done soon. So to summarize, what I would like to say is, wooden pellet is good, it is already proved, but we should also think about how to make best utilization of the local biomass resources, which is specific from region to region of India, India being such a vast country. And shal leaves is a classical example of that. Thank you.
Thank you so much, sir. That was a lovely presentation by Dr. Shumantra Bhattacharya, Professor, IIT ISM Dhanbad. Well, people, I told you earlier that we are having this lovely webinar, and today we are going to give out some prizes. Sir, I'd like to request you to please stop this screen sharing from your side, sir. Screen share, sir, stop the screen share. Okay, thank you so much. Thank you. So today we are having a discussion where it's a webinar on technical feasibility of coal biomass co-firing for thermal power plant organized by Engineers Welfare Forum WBPDCL in association with IIT ISM Dhanbad, CEA, NTPC and National Mission on Use of Biomass. So right now I'm going to announce the winners. Exactly. In the beginning, I told you that the participants, those who are watching this lovely webinar, they are watching this webinar, and then also they are going to be the part of lucky draw winning session. And now we have got the names here. The winner of this lovely webinar for today are Arudipa Chaudhary. Congratulations, Arudipa Chaudhary. Next, Orun Pine. Congratulations, Orun Pine. Orun Avodas, congratulations. Shomir Kumar Dotto, congratulations. Shomika Jana, congratulations. Shurujit Kumar Goswami, congratulations, sir. Shopon Kumar Bala, congratulations. Dibbendu Ghotok, congratulations, Mr. Ghotok. Gurneep Singh, congratulations. Ishita Das, congratulations, ma'am. Nirupam Bose, congratulations. Ashish Modak, congratulations. Dr. Deepak Singh Panwar, congratulations. Piyush Sharma, congratulations, Mr. Piyush Sharma. Shulong Das, congratulations, ma'am. Shubhojit Das, congratulations. Rajesh Pandey, congratulations. Shomojit Dotto, congratulations, sir. Oshim Shena, congratulations. Shabaz Hussain, congratulations, Janab. And they are the lucky draw winners for this lovely webinar. Congratulations to all the participants and those who became the winner in this lovely event. Thank you so much. Thank you so much. Well, moving to our next session, that's the panel discussion. Rather, we have got some questions here in our chat box, and I'd like to convey the questions to our designated panelist. And there's a first question coming from Debobroto Chaudhary. Well, it's a question to Mr. Senghal. Okay, Mr. Senghal, are you here?
Yes, sir.
Yeah, there's a question for you. The use of biomass is commercially profitable. What do you think?
Sir, first thing is that we are not firing the biomass for the commercial profitability. And second thing is when we are firing the biomass, then the ECR increases. Jैसे for NTPC Dadri, NTPC Dadri stage 2, when we are using 100% coal, the ECR is around 3.57 rupees. But when you are using with biomass, then ECR increases to 3.62. But as explained by Omkant Sukla sir, that the increase in ECR due to the biomass will be passed on to the user. So there will be no commercial loss to the power plant if we are using the biomass. I think I answered the questions.
Yeah, thank you so much. Thank you so much, sir. Thank you so much. Well, this is a question coming from, let's see, moving to my next question. Okay, which companies are currently producing this biomass? Dr. Shumantra Bhattacharya, if you could give the answer. Which companies are currently producing this biomass?
So
it's coming from Mr. Ashish Modak.
Whatever biomass we have used distributed forests of Bankura district. But my discussion with district forest officer indicated that if on regular basis such a supply is required through village self-help groups, it can be organized because they are already there supplying various forest products to West Bengal Forest Development Corporation. So through the same network, it can be organized.
There's a related question from Mr. Ashish Modak. Is it suitable for front-fired boiler?
That is difficult for us to say because we carried out only laboratory scale experiments. we did not so far use commercially or even on a pilot scale in any power plant. In fact, that should be possibly the next level of the study.
Okay. Thank you so much, sir. Thank you. The question for Mr. Shubhojit Aich, is there any effect on NOx pollution? This is the question coming from, say, Mr. Ashish Modak.
In most of the biomass, we have seen that from ultimate analysis, the nitrogen content is comparatively lower as compared to coal. So there may be a reduction in NOx pollution overall.
Okay. Thank you so much, sir. Thank you.
In continuation with what Subhajit says.
Yeah, sure, sir.
Nitrogen is always there in coal as well as in the biomass. And even in the direct combustion, we use the air. So nitrogen NOx is not an issue from any of the source fuel. If any fuel have higher amount of nitrogen, even it does not create any problem, because NOx created by the burner temperature in the boiler. So it is a normal design of boiler that they can handle any amount of nitrogen from the fuel, because already nitrogen of 80% is available from the air, primary air or secondary air. So nitrogen is not the issue, but sulfur can be the issue to concern.
Okay, Dr. Nandi, there's a question for you. What is the cost of biomass compared to coal per ton? There's a question coming from Shubhojit Datta.
The cost of biomass is mostly that the collection cost and other things. So if we collected this biomass, so obviously initially it is a free of cost, only the collection cost and some of the sorting, removing some dirt and other things is there. So already, even if we pay some money to them, that will be a social economical impact. So we cannot consider it like a cost-effective production. Rather, it is a social economical aspect of rural people, forest people. So in this way, we have to consider it.
No,
just like we are considering the agricultural waste.
Let me add that given the current landing cost of coal, landing cost of biomass would be very little. Main issue is paying the wages to those who will collect, some commission for the agency, and then transportation cost. Even cleaning dirt and all those things, that cost will also be minimal.
Okay, thank you so much. We have got a big question. Yeah, it's a very large size question coming up here on my screen. But before that, I'd like to request Dr. Bhattacharya to please set your camera in a perfect profile. Your head, only your forehead is visible on the screen. Yeah, thank you so much. It's much better. Thank you so much. Well, the question is a big question, the large question coming from Mr. Binoy Chaudhary. During an on-site study while co-firing coal and biomass pellet in a leading coal-based thermal power plant, the following has been observed. As the mill temperature was to be reduced to accommodate biomass to raise the outlet temperature above 55 degrees centigrade, the coal feeding to the mill was to be reduced. However, the net reduction in mill outlet temperature caused an increase in flue gas exit temperature at our inlet to ESP. So there's a question here. Is there any way out or any way to control this back to normal to reduce the loss through flue gas?
First, I would like to say that whenever we are firing the biomass, then there is a constraint that we need to maintain mill inlet temperature below 180 degrees. So for maintaining that temperature, we are using the cold air. So it is reducing the air flowing through the air preheater. So that's why the flue gas exit temperature are increasing. So we cannot remove the losses, but we can optimize the losses. Suppose we want to feed the 50 metric ton of biomass. So in spite of feeding 5% mixture, we can feed the 10% mixture in only one mill. Because when we are using the single mill, then we can reduce this loss. If we are using multiple mills, then we will have 2 mills which will be having the lower mill inlet temperature. So losses will become very high. So we need to minimize the number of mills which we are taking in service using biomass.
Okay, thank you so much. That was the answered by Engineer Vivek Singhal. Yeah, thank you so much. It's conveying your thank, Bina Chaudhary, your thank to Engineer Vivek Singhal. Thank you so much, people. And today we had a great Sunday. Rather, we're discussing in the topic where it's technical feasibility of coal biomass co-firing for thermal power plant, organized by Engineers Welfare Forum WBPDCL. And we'd like to convey the heartiest thank to IIT ISM Dhanbad, CEA, NTPC, and National Mission on Use of Biomass. And I would like to convey my heartiest thanks to all the dignitaries and panelists and the participants who have participated in this lovely webinar. But before ending this session, I would like to request Engineer Shuman Shorkar, Executive Member, CEC, Engineers Welfare Forum, to please say a few words and say to the dignitaries in this lovely webinar. Over to Engineer Shuman Shorkar, Executive Member, CEC, EWF.
Am I audible?
Yes, sir. You are audible, sir.
Thank you. Double burning were resorted to dispose of unutilized paddy straw in northwest India, preferably in Punjab, Haryana, and UP during the months of October and November every year. This has resulted in deterioration of air quality in the region.
I'm extremely sorry to interrupt you, sir. Mr. Shorkar, you are not visible on screen. It's a
okay.
Please come on screen, please. It's a request. Thank you so much. I'm extremely sorry to interrupt you. Extremely sorry for that.
Okay. I'm restart now. Stubble burning were resorted to dispose of unutilized paddy straw in northwest India, in Punjab, Haryana, and in UP during the months of October and November every year. This has resulted in deterioration of air quality in the region. Government of India has undertaken national mission for use of biomass in thermal power plant to use this unutilized paddy straw. This will help us in generating electricity, save coal, and improve the environment. This is a win-win situation for farmers, power producers, pellet manufacturers, and environment. Only the cost of producing electricity may increase. Engineers Welfare Forum has aptly chosen this topic, technical feasibility of coal biomass co-firing for thermal power plant. Our panelists have dwelled on the technology involved, the advantages that have been accrued, the problems faced in implementing, which would be an eye-opener for all participants, especially from WPDCL, who would embark on a journey of co-firing in near future. I would like to thank all panelists for taking the valuable time to share their knowledge and experience. I would also like to thank the people concerned who have put in their heart and soul in making the webinar a success. Lastly, a big shout out for the enthusiastic participants, without which the webinar would have not been successful. We at the EWF are constantly striving to arrange for meaningful webinars time to time, so that our quest for knowledge remains unabated. Till then, a goodbye.
Thank you so much, sir. That was a lovely ending speech by Engineer Shuman Shorkar, Executive Member, CEC, Engineers Welfare Forum. And I, Kunal, on behalf of Engineers Welfare Forum, WBPDCL, signing off from this lovely webinar. And before signing off, I'd like to say a few words. Keep yourself fit, keep yourself happy, and always maintain protocol for COVID-19. Thank you so much. Wish you a great day and a great year ahead. Thank you so much, everyone, to all the beautiful people, panelists, and to all the participants.
Thanks, sir.
Keep yourself fit, keep yourself happy, and